Let me see. All right. So section 6.3, we're going to be multiplying higher degree radicals with variables. Okay. So it is going to have variables in the actual problems. Now, we're going to still treat the variables the way we did before in section 6.1, where you have to kind of try to make sure that the index matches the power. We're going to still do that. But now we're going to be able to multiply things. Now, here's the thing about multiplication. If you remember what we did yesterday, when we were adding and subtracting radicals, you could not combine radicals that were different, right? You couldn't do radical 2 plus radical 3. That was not allowed, okay? Because they were different. They weren't like radicals. Multiplication says, I don't care about your rules. I'm multiplying everything. Okay, the inside and the outside. So in other words, this little mini example that I have out here, 2 radical x times negative 6 radical 3x, I'm going to multiply the numbers on the outside. 2 times negative 6 is negative 12. And then I'm going to multiply the inside of the radicals. Now make sure that the radicals at least are both square roots or cubed roots. Okay, that's important. They should match, but the inside doesn't have to match. So on the inside, x times 3x is 3x squared, right? X times 3x. So I multiplied 2 times negative 6 and then x times 3x, right? Well, can I simplify the square root of 3x squared? Is there a square root to 3? No, right? Can I take an x out for a square root of x squared? Now, I will remind you the index here is a 2. Can I take an x out? I can, right? Because the index matches the power, right? This power right here and this index, they're both 2's. That means that this x can come out. So my final answer will be a negative 12x square root of 3. So what makes multiplication simple is that it just doesn't care. Okay? It doesn't care if the radicals match. It doesn't care, well, it does care if they're not the same index, but most these questions will all have the same index. It doesn't care if the radicands are different. It doesn't care what the numbers are in the front. It's going to multiply the numbers in the front. It's going to multiply the radicands. It doesn't matter. Okay? Whereas addition and subtraction, that's a big deal. If they don't match up, you can't do it, right? Multiplication says, throw that out the door. We're just going to multiply, okay? The main thing, though, is after you multiply, you're going to want to simplify, okay? So make sure that you always ask yourself, can I do anything else with this, okay? So for this first example, and there's only one example, it's A through F. I don't know why I call it example 1. I just call them 1, 2, 3, 4, 5. But it's example 1, A, B, C, D, E, F. There's a bunch of these, okay? But they're not too difficult. So we're going to simplify part A. It says square root of 10 times negative 3 square root of 5. Now notice there is a 1 here, right? Right in the very front, there is a 1, okay? So 1 times negative 3, that's negative 3, okay? Square root of 10 times 5, well, that's 50. So I'm done, but I can reduce 50. What 2 numbers can I multiply that give me a 50, but one of them should have a square root? I want a 50. 2 times 25. Yeah, 2 times 25. So I'm going to make this negative 3 square root 25 times 2. What's the square root of 25? 5, right? So that's going to be negative 3 times 5 is negative 15 square root of 2. And I'm done. I like this better than addition and subtraction because there really is no rules that you can't like multiply things. Like you can multiply everything. The front numbers with the other front numbers, the inside numbers with the other inside numbers, right? Now I'm not going to multiply 15 times 2. Now that's not allowed. Don't go from outside to inside. Okay, inside multiplies inside, the outside multiplies outside. Okay, but that's it. Just simplify. Okay, question always that I'm asked is, could I do this on the calculator? Yes, you can do these on a calculator. If they're square roots, you could have on your calculator typed in square root of 10 times -3, square root of 5, hit enter, and it would have given you -15 radical 2. It can do these. Okay. Once the letters come in, it can't do those. Okay. Or if we're dealing with cubics, it can't do those. Your calculator can do this one. Okay, it can do this one. You just got to type it in. 2 radical 3, parenthesis, radical 10 minus 5 radical 3, end parenthesis, hit equals. It's going to give you the correct answer. Okay, now I will ask you, please don't get lazy. Don't just use the calculator the whole time. Okay, learn how to do this. And once you know and you get it, then use a calculator. Okay, I hardly ever use a calculator as a teacher. Not because, it's all in my head or anything. No, it's just, I know how to do it. So instead of having to pull out a device to punch numbers in, I just do it in my head, right? When I can, not always, but when I can, right? The calculator though is a tool that's meant for people who know how to do stuff, not for the kids that don't, right? It's always been meant as a shortcut for the people that already do the stuff in their head. So, all right, so here we go. For this, we're going to follow a rule that we normally do, which is we're going to distribute. Okay? Now, remember, in front of this radical 10, there is a 1. I just want to remind you that. So when I distribute 2 radical 3 times 1 radical 10, well, 2 times 1 is 2, and radical 3 times radical 10 is radical 30, minus, and now the next one, 2 radical 3 times 5 radical 3, well, that's 2 times 5 is 10, and radical 3 times radical 3 is radical 9, because 3 times 3 is 9. Can I break 30 into 2 factors, one of which has a square root? I need a 30. So 30 is 1 and 30, 2 and 15, 3 and 10, 5 and 6. None of those numbers have nice square roots. So that one's stuck. This is stuck. That's all it can be. Minus. Now, square root of 9, I know that. What's the square root of 9? 3. So that comes out. That becomes 30. And my answer is done. I do not combine 2 radical 30 minus 30. You cannot subtract them because they're not the same radicals. Now, if the 30 was a square root of 30, then yeah, I can do that. I can combine those. Okay? But I don't need to do that. I'm done. Like I said, multiplication is way easier than division. And not that division is crazy difficult, but there's this thing called conjugates, which we'll get into, that make it a little bit more complicated. We don't have that here. All right. So obviously, if I was just able to distribute, then I should be able to FOIL, right? Or do a binomial distribution. So that's what's going to happen here. I'm going to distribute these two, and then I'll do these two. Okay? And you should feel comfortable doing this because we've done this before, right? And just with normal numbers and letters. So it's not like this is all brand new. It's just different, right? So for the very first one here, we have radical 2 plus 5 radical 5 in a binomial. And then we have radical 2 plus 3 radical 5 in its own binomial. And I'm going to distribute. So I'm going to start off with radical 2 times radical 2. That's radical 4. Okay, radical 2 times radical 2 is radical 4. Now, radical 2 times 3 radical 5, that's 3 radical 10, because 2 times 5 on the inside becomes a 10. The 3 times 1, remember there is a 1 here, right? 3 times 1 is just 3. Okay? Now, the green stuff. 5 radical 5 times radical 2 is 5 radical 10. And then the last one, 5 radical 5 times 3 radical 5, that's 15 radical 25. Now let me simplify as much as possible. What's the square root of 4? This comes out, what do I get? That's a 2. Notice 3 radical 10 plus 5 radical 10 is 8 radical 10. I can combine those by adding. Okay. And then I have a square root of 25. What is that? Square root of 25. 5, right? And 5 times 15, well, I know 4 times 15 is 60, so 15 more is 75. So it's going to be 75. Okay, because the 5 comes out, 5 times 15, 75. Now, add 2 plus 75, that's 77. Now, before I write the next term, can I break up 10 into two factors that one of them can give me a square root? So 10 is 1 and 10, 2 and 5. That's it. None of those numbers have a square root. So this is basically 8 radical 10, and I'm done. And what do you guys think? Is this like crazy difficult? I mean, it's just multiplication, right? You just got to remember the outside numbers with the outside numbers, inside with the inside. And then you just got to simplify, which can be the tough part. Simplification can be the tough part. Now, some teachers will teach it one way, some will teach it a different. I tend to teach it the longer way, but it's really not longer. Okay. But some teachers will tell you, you know what you should do is immediately simplify as much as possible, which you can do. And then other teachers will say, no, don't simplify first, just multiply and then simplify after. Because sometimes when you simplify first and then you multiply stuff out, you still have to simplify later. So you either simplify, do the work, and then simplify again, or do the work and then simplify. So for me, I'm like, well, why am I going to do three different things? Let me just do the two things. I'm gonna multiply it out, then I'll simplify after. Okay, so that's what I'm going to show you guys. So let's multiply this. There's a negative 1 in front of that one that doesn't have a number. So negative 1 times negative 4 is 4. Square root of 3 times 15, that's 45. N cubed times n cubed is n to the 6th. Okay, because there's 3 n's and then another 3 n's. I'm going to multiply them together. That's 6 n's altogether. So it's n to the 6th. Now I'm going to simplify. What can I break 45 into so that I can take a square root of something from it? What times what? Something does work. 9 and 5. Thank you. 9 times 5. Okay? Because the square root of 9 does exist. And then what's my index on a square root again? The little number on top of the radical? It is a 2, right? A little 2. So that means my n to the 6th, I need to write them out as squares, right? N squared, n squared. So that's going to be n squared, n squared, n squared. That's n to the 6th, right? 2 plus 2 plus 2, that's 6. So the 9 will come out. And this n, and this n will come out. Okay? Because the index matches the powers. So here we go. When the 9 comes out, it becomes a 3, right? The square root of 9 is 3. So 3 times 4, that's 12. 3 n's come out. So n times n times n is n to the 3rd. Square root of, what's left? Just a 5, right? So here we go. This is my solution. So these are the problems that I would say these are the harder ones, okay? Because now we're dealing with variables and numbers, and we're trying to break everything down. Again, these are homework problems, so hopefully you guys don't mind if I kind of go a little bit long. We're only 14 minutes in. I told you it was going to be about 25, right? So I'm still about 10 minutes away. But this is when it kind of starts to get a little bit more hairy, I guess you could say. Okay, because now we got variables, and if you didn't get the variable stuff from 6-1, you're going to have to practice, guys, because it's going to start popping up. We got 2 more, okay? The next one doesn't have any variables, but it is cubic, okay? And then the last one has both variables and is cubic, and that's it. So, trying to think, 1, 2, 3, 4, yeah. So, right here we have a cube root of 20 and a cube root of 25. Remember, I'm not the type that likes to tell you simplify each one and then multiply after and then simplify again. I just want to straight out multiply. This is cubed roots. In front of the cubed roots are ones, right? There's a 1 here in the very front, and there's a 1 here. So 1 times 1 is 1. I'm not going to write it because why? There's no reason to. But there are 1s there. And then cubed root of 20 times 25. Well, I know 2 times 25 is 50, and then I just drop a 0. So there's going to be 500. Okay? And now I got to think, okay, what cubed root do I know that can that can divide 500? So remember, the numbers are 125, 64, 27, and 8. Does 125 divide 500? It does. 4 times. Okay? So this is the cubed root of 125 times 4. What's the cubed root of 125? See if anybody remembers. What times what times what is 125? It's 5, yeah. So 5 cubed root of 4. And I'm done. So, I mean, this isn't terribly difficult. It's very straightforward, right? The number got a little big, but remember, you're just thinking, okay, divide by 125 first. If that doesn't work, try 64, try 27, and try 8. Why do we try those 4 numbers? Because those have cubed roots, right? Those have cubed roots. So we try those. All right, last one. I'm pretty sure I'm going to be way under the 25-minute mark, so that's good. The last one does have variables in it. The other one didn't, but that's okay. Not a big deal. We'll deal with them. So part F, the cubed root of negative 10 n to the 4th times the cubed root of 24 n to the 3rd. Okay? Now, I told you guys that whenever you do cubed roots, if there's negative inside, take it out, right? So that's the first step I'm going to do. I'm going to write negative cubed root of 10 n to the 4th times the cubed root of 24 n to the 3rd. Okay? So there we go. Now, I'm going to go ahead and multiply. Negative 1 times 1 is negative 1. Okay, so I'm just going to put a negative there. Cubed root 10 times 24 is 240. N to the 4th times n to the 3rd is n to the 7th. Now remember, my index has to match my power, so I'm going to have to break that 7 down into 3s, right? So it's going to be a 3, 3, and a 1, right? Because 3 plus 1 is 7. The index will match the powers if I make them 3, 3, 1, so that's pretty good. 240, though. Can I divide 240 by 125? So again, this I'll bring out calculators for you guys, but that won't work, by the way. But can I divide it by 64? That I'm not sure. No, I cannot divide it by 64. Can I divide it by 27? No, 8.888. That's not good. I know I can divide it by 8 because 8 divides 24. So 8 times 30. Okay, so this is going to be negative cubed root 8 times 30, n cubed, n to the 1st. Okay, if you want to write a 1, go ahead. I'll put it there. But you don't have to. N to the 1st or n, same thing. Okay, I'm going to highlight my index with powers just to kind of do that early right now. So these are going to come out. The cubed root of 8 is 2, so it's going to be a negative 2. And then 2 n's are going to come out. Okay, let me kind of move this thing here. Negative 2. 2 n's will come out. That's n squared. And this will be the cubed root of what's left over is a 30 and an n. And that's it. So today's homework, is going to be based on this. Okay. So this is what I'm going to do right now. On your computer, or you can grab your phone. I'm going to have to let you guys do this, even though it's not what we normally do. That way you can use your phone. You can go to Google Classroom. I'm going to throw this assignment out there right now, okay? Because again, I don't have a paper copy of it. That way, if you want to start doing it on piece of paper, go ahead. I will get copies of it during rally. So if you want to come back and grab one, that's fine. If not, you can grab one on Tuesday, but I really recommend you try to get it done prior to Tuesday because that's review day. But yeah, just look for the assignment on Google Classroom, okay?